after that. So all the results that I share today is all preliminary results. So please do not share them right now, and we will update them all afterwards. So for the tracking data, just as Amanda has introduced yesterday, we deployed 22 Far Eastern curlews with the satellite tracking devices from 2017 to 2019, all around its non-breeding grounds in Australia. So we then generated tracks and sites from the tracking data and calculate the centuries for each site that we defined, and then buffer it with a 20-kilometer radius. So that's what a site looks like in our analysis. It's a 20-kilometer radius, and we use that circle to overlay it with the habitat data and calculate the tidal flat area within it. After calculating the habitat area, because of the variation of detected tidal flat area in different time slices, we then excluded all the outliers of the estimates of tidal flat area in certain slices, and then fit a linear regression to detect the trend of the habitat change. So we calculate the relative annual percentage change as our index of habitat change. So that's our result. We generated 34 migration tracks and 145 sites from 21 curlews that has habitat data. And as you can see in this figure, there are very large variation between tracks. Some of the tracks have consistent negative habitat change, and some of the tracks would have better situation. And afterwards, for the individual birds within each track, the variation is still very large between the sites. So the worst site is significantly have significantly lower value of annual percentage change than the median sites and the best sites. This means that habitat loss is strikingly uneven across the sites visited, and hints that rapid loss at a small number of locations is compromising the migration journey of most individuals, which shows us that there might be some possible bottlenecks along their migration route. So afterwards, we investigate the spatial pattern of the habitat change along the migration route of Far Eastern curlew. The left figure shows the sites that we generated, and we incorporate the classification scheme from Nick that we classify the sites as decreasing if it has a annual percentage change lower than -1.5%. So all these decreasing sites are concentrated in East Asia area, and there's no significant trend for other sites along the Flyway. And for the right figure, the lines with red color means that on that track, the bird used at least one site that was decreasing trend. So over half of the birds are actually using sites with decreasing trend along their migration route. And finally, we calculated the cumulative exposure to habitat change en route for birds. Just take this one as an example. The line is a track, and the point on it is a site. for this one, the first non-breeding ground has a percentage habitat change of minus 0.81%, and the first stopover site has a habitat change of minus 1.27%. So we calculated as multiply them throughout the migration route and get the product of habitat change at sites across the tracks. So that's all the tracks, and the dashed line shows the incomplete tracks that the birds didn't have the data from the non-breeding ground to stopover site to breeding ground, then stopover sites, and finally back to the non-breeding ground. That's a complete track. And if the bird doesn't meet that requirement, and then it's an incomplete track. And we didn't find significant difference between incomplete track and complete tracks, but most of the tracks, actually 58.8% of the tracks have a cumulative habitat change under 1, which is quite worrying because it means that even though they might have some better size, and in result, the cumulative exposure to habitat change is still not that good. So in conclusion, sites varied very largely in the percentage change rate of the extent of tidal flats, and the rates ranging from minus 3.36 to 6.64%. And half of the individual analyzed were exposed to habitat loss in one or more of their stopover sites. And spatially, sites with decreasing trend in extent of tidal flats were concentrated in East Asia. And cumulative exposure to habitat change en route is quite worrying. So the most important take-home message here is that we need to assess the effect of habitat change across the whole migration route because of the variation between sites and also the migration connectivity of the birds. So thanks for all the co-authors and friends that helped us study.